This video is for section 8.1. We're finding angle measures in polygons. On this slide, we're going to look for the exterior angle measures. So we have every single interior angle measure. How would you find the exterior angles? Remember, interior angles and exterior angles here make a linear pair. So these have to add to 180. So if that's 60, that's 120. That's going to mean that's 125. And this one down here would be 115. We have our three exterior angles. In this triangle, there's three interior angles. There's three exterior angles. Those three exterior angles, if you add these three numbers up, they add up to 360. In this shape, you have all four interior angles. The four exterior angles, remember, are supplements of those interior angles. If you add those four angles together, you get an exterior angle sum of 360. Notice how the interior angle sum here was 180, but the exterior angle sum was 360. In this shape, the interior angle sum is more than this shape. It's 360, and the exterior angle sum is still 360. It's the same as that one. This one, let's find our exterior angle measures. It's a six-sided shape, so there's six interior angles, there's six exterior angles. What are these six exterior angles going to add up to? You add those six numbers together, it's going to give you 360. The interior angle sum is different than this shape, and it's different than this shape. But the exterior angle sum is the same in all of them. It's always 360. Okay, and that's not a coincidence. Theorem 8.2 is the Polygon exterior angles theorem. It tells you that the sum of the exterior angles of a convex polygon, one at every vertex, is 360 degrees. So what's the exterior angle sum for all of the octagons? For all octagons. So all 8 angles in an octagon that are exterior, what do they add up to? 360. How about the exterior angle sum for quadrilaterals? 360. Exterior angle sum for hexagons? 360. Decagons? 360. 102 gons? That's 102 exterior angles. What do they add up to? 360. You don't need a formula for the exterior angles. The exterior angles are always 360. That makes things a lot easier. So in this particular example, you know that these four exterior angles add up to 360. So I'm just going to model this with an algebraic equation. I'm adding my four exterior angles. I'm setting them equal to 360. Just going to combine my like terms there. 89 and 67, I'm typing that in. That gives me 156. I know together that's got to be 360. So if I subtract 156 from both sides, I get 204 over here. And that's what 3x is. So if I divide by 3, I get 68. So that's the value of x, 68. This guy would obviously be 2 times as big. Okay, so let's apply the Polygon exterior angle theorem to this word problem. A convex hexagon has exterior angles with these measures: 34, 49, 58, 67, and 75. What's the measure of an exterior angle at the 6th vertex? Well, we know all 6 angles add up to 360. So let's subtract away those 5 angle measures that we know. So whatever that sum ends up being, we got a 34, we got a 49, we got a 58, a 67, and a 75. That gives you 283 degrees in your exterior angles. We know it has to be a sum of 360. So we're doing 360 minus 283. Gives you 77. Here's some recall on definitions. Equilateral polygons, they have all sides congruent. So that's an example of an equilateral polygon. But if you look at these angle measures, that one's acute, that one's obtuse, they're not the same. Equiangular polygons, all of the angles are the same. But the sides clearly are not. This top is way longer than that side. If you have a regular shape, then all of the sides are the same. And all of the angle measures are the same. That's a review. And it's really important to know what a regular polygon is. So when they give you regular polygons, obviously all of the interior angles are going to match, which is going to force all of the exterior angles to match as well.